This is Ham College, episode 48 for December 31st, 2018. Ham College is brought to you by ICOM and the soon-to-be-released IC9700. You're going to want to keep this rig on your radar. And by hamstudy.org, a great way to study for your next license exam. Good evening and welcome to the final episode of Ham College for 2018. I'm Professor Thomas.
And I'm Dean Martin.
And it's good to be back with you again. We almost didn't make it there for a minute, did we?
It was a bumpy ride. Be sure to fasten your seatbelts tonight because we can't predict turbulence.
Yep. And the stewardess, well, they're not stewardess anymore, are they?
Flight attendants.
The flight attendants will be passing out peanuts and bottled water in a little bit.
And barf bags.
Barf bags. Okay. Maybe we won't go that far.
It's going to be bumpy.
Yeah. All right. Well, tonight we've got, well, like I say, it's the final episode for this year.
That sounds so permanent.
Not yet.
It's the grand finale of 2018.
Okay. I'll go with that. What did we talk about on the last episode?
That's a real darn good question. Speech processors, ALC, and beverage antennas, to my recollection.
My mouth's watering just thinking about it. That's an inside joke from an old episode. But anyway, yeah, that's what we talked about. What are we gonna talk about tonight?
Well, we're going to talk about
overmodulation.
With that, we are.
And we're going to talk about
a little bit about oscilloscopes, I think.
Yeah, a little bit about test equipment. Probably a little bit about dogs barking.
Probably so. And I'm predicting at least a couple of buzzes tonight.
You think?
It could possibility.
Happen. I mean, now's the last opportunity on the end of year closeout here.
Yeah.
You want to get those buzzers in while you can.
Yeah, no doubt.
Okay, yes, that was a weather dog, Ralph. And while it's not raining right now, apparently he's running late.
Yeah.
Because, boy, it rained yesterday.
Yeah, and it's more coming, too.
We had a flood in the backyard.
I've been home, not off work, but working from home for 3 weeks so far. I've still got right at 3 weeks. And it's rained so many days, man. I have hardly even gotten out to do any of the stuff I wanted to do outside.
I know. And apparently I've got problems with my brand new mobile antenna.
Yeah.
We were talking earlier today.
We're trying to.
Trying to, yeah. Either that or that 15-year-old rig is finally playing out. I don't know.
Maybe, but I would suspect the antenna you just changed.
Yeah, probably so. And that's a shame too, man. That's a brand new antenna, and that wasn't one of the El Cheapos like I usually buy.
No, but you know that same model you've got. I had trouble out of that one.
Really?
Yeah, it's the only one I've ever had that seemed to have like a short like inside of the base of it. I never did. I didn't try taking it apart. I guess I should. I've still got it.
Yeah. Well, and it's starting to rain again tomorrow, so I don't know when I'll get to it, but
hey, you can unscrew it and bring it inside.
Well, I guess so, but then I can't really test it like that, kind of.
Because of how much testing you want to do.
Yeah, I need to do some though. I got all this nice test equipment. I should use it for something. Well, I think we have stalled about long enough. Maybe we could get on into the show now. Oh, there's something we always mention at the top of every show.
Yep. the chat room. Join us, AmateurLogic.TV/chat for the chat room and kind of participate along. If you're watching the live stream, there's a nice crowd in there, and they kind of answer along as we're going through the questions, and it's a lot of fun.
Mm-hmm. It is a lot of fun, and that's where we get a lot of the answers sent to us. Not always the right ones, more often than not, though.
Yeah, mostly.
And yes, Craig, it is a live chat right now. If you're watching live, if you're watching the recorded version, we can't really talk about that.
it's Memorex.
Yeah,
it's not
if
live.
you go in there, you might not get any answers. But
there's always somebody in that chat room, though.
Yeah.
Every once in a while, I just pop on there just to see, and there's always somebody hanging around in there.
But are they saying anything?
Not with the periods that I'm in there.
All right, first question tonight. Well, since you're so raring to go, I think I'll ask you this one.
Okay.
Which of the following is an effect of overmodulation? Is it A, insufficient audio?
B, insufficient bandwidth.
C, frequency drift?
Or D, excessive bandwidth. Okay, this one I think I know. It's not going to be insufficient audio because you got too much. You're overmodulating. It wouldn't be insufficient bandwidth or frequency drift because that's separate. A frequency drift is separate. It's going to be excessive bandwidth. If you're overmodulating, your signal is going to take up too much of the spectrum.
I'll agree with you, and so does the chat room. And let me say, since we got them on low latency tonight, as soon as it popped up, they were just DDD. So everybody's saying D in there. And no, we didn't say. Wow. Someone mentioned in there you didn't say whether it's AM or FM. No, because it's sideband. No, we don't really know what it is. It
doesn't say.
This is the question that's on the exam. It doesn't say, but yeah, just about any mode. If you're going to overmodulate it, you're going to be splattering and taking up more bandwidth than you should. Okay, you got one for me?
I do. I just so happen to have one right here. Oh, this is a good one for you too. What is meant by the term flat topping when referring to a single sideband phone transmission? A, signal distortion caused by insufficient collector current.
B, the transmitter's automatic level control, the ALC, is properly adjusted.
C, signal distortion caused by excessive drive.
Or D, the transmitter's carrier is being properly suppressed. What is meant by the term flat topping when referring to a single sideband phone transmission? Signal distortion caused by insufficient collector current. No, it might not even be a transistorized rig. B, the transmitter's automatic level control is properly adjusted. No, you wouldn't. Flat topping is not a desired characteristic. So we know it's not properly adjusted. C, signal distortion caused by excessive drive. That's a good choice there. And let's see, D, the transmitter's carrier is properly suppressed. No. Nope, it's going to be C, signal distortion caused by excessive drive. The chat room, well, they were all over that one too there.
Yeah, that low latency thing, that's kind of going to take some getting used to, because normally after we get through reading the questions, I can look down
and they're just
starting to pop in, and now they're like every one of them, tons of them already before we get done.
That's what we're talking about there is some new settings available in the YouTube stream there where we can decrease the latency on the stream so the people watching live are seeing it really just about as soon as it happens instead of the normal delay that there would be there. So I have another low latency question for you then. Which of the following can be the result of an incorrectly adjusted speech processor? A, distorted speech.
B, splatter.
C, excessive background pickup.
Or D, all of these choices are correct. Well, distorted speech certainly can. Splatter certainly can.
Yeah.
Excessive background. The answer's got to be D. All of these choices are correct.
And that's what everyone's saying over in the chat room there, and that is correct. You'd hear all of those. If somebody had a speech processor really cranked up, it'd be distorted and signal would be splattering, and you'd hear every little piece of background noise being sucked up in between your words.
What signals are used to conduct a two-tone test? A, two audio signals of the same frequency shifted 90 degrees.
B, two non-harmonically related audio signals.
C, two swept frequency tones.
Or D, two audio frequency range square wave signals of equal amplitude. Boy, let's just analyze those there. What signals are used to conduct a two-tone test? Two audio signals of the same frequency shifted 90 degrees? No. All that would mean is they're canceling each other out a little bit. B, two non-harmonically related audio signals. That's what I think the answer is. C, two swept frequency tones. No, you don't sweep the frequency. That means you start at, say, like a low frequency and you're sweeping it up, increasing the frequency.
Okay, ramping it up.
Yeah, you don't do that. And D, two audio frequency range square wave signals of equal amplitude. Now, you don't use square waves for that. I'm going to say B, two non-harmonically related audio signals. And everybody's getting that right over in the chat room too. It is B, and the reason you'd use non-harmonically related audio signals, if they were harmonically related, say like 1,000 hertz and 2,000 hertz, some of what you're seeing might be harmonics off one or the other, and you really wouldn't know it.
That makes sense.
This is cheating, man. You just asked me, and I gave you the answer to this.
I didn't know it was coming.
Yeah. What type of transmitter performance does a two-tone test analyze? Is it A, linearity?
B, percentage of suppression of carrier and undesired sideband for single sideband.
C, percentage of frequency modulation.
Or D, percentage of carrier phase shift. I'm going to have to go with A on that, Alex.
There you go. You know what linearity is?
Nope.
Okay.
Explain that one to me. Is that on another question coming up?
No, I don't think that's on a question. But this would kind of explain a linear amplifier too, almost. It would apply to it. Linearity. Let's say I took an audio amplifier and I ran two tones in it at exactly the same level. Let's say I ran in a 1 kilohertz tone and I ran in a 55 kilohertz tone at the same time, the same exact level. I would then look at the output of that amplifier and see how strong the 1 kilohertz tone was and how strong the 5.5 kilohertz tone was. And if they're the same level, the amplifier is linear. But if it is rolled off and the 5.5 kilohertz signal is lower, then it's not really linear, because it's not passing what's coming in at the same level.
It's alternate.
Yeah, it's rolled off. It just doesn't have the band pass, and that's what we want a linear amplifier to do. If we put a signal in, we want it to be passed without being modified. We want the same signal that we put on the input to come out the output, just stronger. So there's a cheap explanation of linearity. I'm sure Emil would be proud.
Oh, yeah.
That didn't cost anything.
Well, that was good. That's interesting. I've seen the term before, but I didn't know what it meant.
That's pretty much what it means. It was a big deal when I was working in television back in the old NTSC days, because a television signal is 5 megahertz wide. And if you don't tune that TV amplifier just right, or the transmitter, you'll have all kinds of problems. I mean, it's got to be tuned linearly, because if you got roll off on it, you know, the colors could be washed out, or you know, all kind of artifacts in the picture. So with 5 megahertz, it's a little chore to keep that linear with an old tube type.
Yeah, I could imagine.
And as a matter of fact, I never could tune that transmitter right. My boss would always have to go back the next morning and touch it up to get
Really?
it, yeah, to get it, you know, back where it should be again. All right.
Nigel's in the chat room.
Oh, he is. Hi, Nigel.
Hey, Nigel.
Wait a minute. He's already passed the exam, hasn't he?
Nigel? Oh yeah, he's got a UK and a.
That's
US
what I'm talking about.
ticket.
Yeah.
Mhm.
Okay. All right. Next question here.
I read this one.
Yeah.
What is the modulation envelope of an AM signal? A. The waveform created by connecting the peak values of the modulated signal.
B. The carrier frequency that contains the signal.
C. Spurious signals that envelop nearby frequencies.
Or D. The bandwidth of the modulated signal. I'm going to say this is a toughie, and you should have given me the answer immediately before asking the question, like I did for you.
Yeah, that would have been the nice thing for me to do.
What is the modulation envelope of an AM signal? Well, I know what it looks like because I've seen it plenty of times on the scope. But this is the correct answer on this one. I never would have. It's not the way I would have explained it. They're all saying A over in the chat room, the ones who are answering. There's a lot of cowards in there that are not throwing out an answer.
Yeah, there are not nearly as many answers on that one as there have been on some of the other ones.
No. What is the modulation envelope of an AM signal? A, the waveform created by connecting the peak values to the modulation signal or modulated signal. B, the carrier frequency that contains the signal. No, that is the carrier. That's not the modulation envelope. That's just the carrier part of it. Modulation's added to that. C, spurious signals that envelop nearby frequencies. No, that's not part of your modulation envelope. That's just junk that you created in the process, which you don't want. B, the bandwidth of the modulated signal. And you would almost think that was it, but no, it's A, the waveform created by connecting the peak values of the modulated signal. How would you explain that to someone? Dean?
I think you're going to have to draw a picture.
I got some paper and a pen right here.
Yeah, I don't know how to draw it.
Yeah.
You got an oscilloscope around here anywhere you can show it on?
Well, I do, but I don't happen to have an AM transmitter sitting right here.
Where'd it go?
Well, I put it up when
put it back up.
we
There was
decided
one
it
sitting
wouldn't
here.
show what I wanted to show.
That might have shown what you didn't want to show.
It would have done that, that's for sure. Gee.
You're the professor. I'm just the dean of admissions.
Yeah, and I wish you wouldn't have asked me to do any explaining this early in the show. So you can see the little bitty waves there are the carrier, and then the outer waveform, that's the audio that's been superimposed on it, or that is
interesting
modulating it. Yep. A lot better explanation than my drawing was producing there.
Oh, come on. Don't sell yourself short. It was pretty good. Got the point across.
It did. But just tell me now, did that really look
exactly like that to me.
okay? All right, well then. I'm not even sure whose turn it is now.
It's your turn to read one for me. Because you just did that one.
All right. What item of test equipment contains horizontal and vertical channel amplifiers? Is it A, an ohm meter,
Or B, a signal generator.
A, an ammeter,
You mean that must C, an ammeter. Or D, an oscilloscope. What item of test equipment contains horizontal and vertical channel amplifiers? Well, I just so happen to think that one is a D, an oscilloscope. I've never seen one in an ohm meter.
Horizontal and vertical channel amplifiers?
Yeah.
No.
And I've never seen one in an ammeter.
No.
And I'm pretty sure my little cheap signal generator doesn't have them either.
I would say there's a good chance it doesn't.
So it's going to be a D, an oscilloscope.
D. So you're saying it's D.
So I'm saying it's D. I take D, an oscilloscope, for 200, Alex.
You got it. There.
I'll
give you that one. That one was easy. I should have picked a tougher one for you.
Well, here, let me see what I'll give you an easy one this time.
You know,
Are we already over in
there
the
may be
electronics?
some folks. No, we're not there yet, but we are at the point where we're going to have to reload our stills here. But I'm just thinking, you know, some people who are not yet amateurs or haven't really dabbled in electronics may not really be familiar with an oscilloscope.
Yeah, that's a possibility.
And you know, I just happen to keep one handy at all times.
Just so happen to have one in your pocket?
I do. Just so happen to have one right here.
Well, that was convenient.
That was a convenient one. And I just happen to have a camera pointed at it.
It's just all the pieces just falling right into place.
Almost like it was planned.
Almost.
Well, if it ever gets booted up here, we'll see. There's an oscilloscope right there. Let's put some tones into it. Guess we ought to turn it down where we're not really distorting it.
Yeah.
And this thing's got, would you believe, a vertical and a horizontal amplifier in it?
No. Say it isn't so.
It's so. It's so. Right here is the vertical input of it. We're running an audio tone into there that just happens to be 750 ohms.
Okay.
And we see a sine wave here. That's the vertical input to the scope. Now, usually there's also a horizontal input on here. That's not used as much. Mm-hmm. It's really not. So we're seeing our vertical signal go like this. It's going up and down. The horizontal is what's going across this way. Well, in most applications of your oscilloscope, what you're actually doing is tapping off a little bit of the signal coming here on the vertical input, and you're using it with the horizontal circuit here so that it's locked to the frequency that's coming in. Now, if it gets unlocked, you know, you could have things like, well, like that signal starts moving around and it won't sit still. But when you run it in some of that signal into the horizontal input, it'll lock in there and sit still where you can see that wave. And you can even zoom on in by adjusting the horizontal frequency there and get it down to where you're seeing a single wave, or, you know, just a portion of it, or multiple waves at once. Now, the horizontal input would be if we wanted to use some other signal to drive the horizontal of the display here, rather than what's coming in for our vertical. There are cases where you'd want to do that. I don't have a good one to explain here today. But on most older scopes, there will be also a horizontal input on there somewhere, so you can do that if you want to. It's not done as much, but it is done for specific measurements. On more modern digital scopes like this, it can just use one of the other vertical inputs to be a horizontal input.
Oh.
So that's the reason I don't have a separate one on there. But that's just a sine wave on an oscilloscope right there. You know, since I've got this scope sitting here, we might want to use it for something else in a minute.
Okay.
So I think I'll leave it sitting there.
It is a handy tool.
It is a very handy
and
tool.
the prices come down on them a lot too. So, you know,
Well, yeah, I mean, back when I was in college, well, they didn't have digital technology like this for scopes yet. If they had, you know, that thing would have probably cost as much as your house.
Oh yeah.
Everything that it can do. And today, a few $100, you know, just depending on how much, you know, bandwidth you want on it.
Yeah.
And how many features. Now, I've still got my old Tektronix oscilloscope up there.
Yeah, I see it.
It's got a lot more knobs than this one.
Yeah, it must be better.
Some things.
Really?
Seriously, there's a difference between analog and a digital scope.
Yeah.
Analogs, some things look nicer on it. I almost pulled it out. Maybe one day in the future we'll pull it out and we'll use it.
Okay.
You can probably even see the screen flicker on it where you don't really notice it on the digital one here when you got a camera pointed at it. But yeah, I kept my old scope too because some stuff is just good for.
I actually pulled mine out today to look for a hum in my audio line.
Did you
my camera.
Did you find it?
I didn't find it. I found out what frequency it was.
That's, you know, you can do that on an oscilloscope. Well, I shouldn't even get sidetracked on this. But if you know the time that you've got the horizontal set for on the scope here, how many milliseconds or microseconds, you can count the distance of a wave there, and you can calculate out the frequency.
Mm-hmm.
And that's how you used to have to do it. But on these more modern scopes, a lot of them, and this one does too, it has a frequency counter built in it. It just calculates that out.
Yeah.
So it is very, very handy piece of equipment to have. If I could only have one piece of test equipment out on Gilligan's Island, though, it's still going to be an analog voltometer.
Oh yeah.
Yep. I could get by with a digital one, but a scope that'd be further down the list. It'll be the second.
Yeah, I use my voltmeter quite a lot. My oscilloscope I bought, I've used it 4 or 5 times probably since I bought it.
But there, I mean, you just paid for it when you troubleshot that $30 microphone, you know, and figured out what frequency the ripple was.
Yeah, it's still the problem is it's still there.
Yeah, well,
I just know what frequency it is.
You just didn't turn the right knob yet. Well, we'll be back in just a moment, but first, let's get a message from our sponsor, ICOM. Listen up, hams. Soon ICOM will be releasing the new IC9700. It's the latest transceiver bringing direct sampling and software-defined receiver technology to the VHF and UHF arena. You're going to want to keep this rig on your radar. The IC9700 is packed with features including all-mode tri-band covering 144, 430, 440, as well as 1200 MHz, center design style 4.3-inch color touchscreen, dual watch operation, and full duplex operation in satellite mode. Smooth satellite operation with normal reverse tracking and 99 satellite channels. D-Star providing digital clear audio and internet-capable communications. Digital data mode providing 128 kilobits per second data communications. Look for the new IC9700 coming soon. Attention all hams. ICOM knows that ham clubs play a big role in bringing ham communities together to learn from their peers and industry leaders. As a way to give back and help you on your mission, ICOM has launched a promotion exclusively for U.S. ham clubs and the Hamfest they're involved with. By registering your club, you could win ICOM swag, a Skype presentation for your club, or your Hamfest and ICOM booth setup. Register today for your chance to win at icomamerica.com/hams. You know, every episode of Ham College, we've got something to give away.
Every time. Never gets old either.
Never gets old.
Nice Ham Crew ICOM t-shirt. Look just as good going to the Ham Fest as you will leaving going home. And a nice ICOM ball cap. Uh-oh.
Yeah, why don't you go ahead and continue on?
Here, I'll model the cap and the shirt. Hold on a minute. Let me put the shirt on.
And I will draw a lucky winner.
Anyway, I finally got me another one of these I mentioned before. And I should have wore it tonight. I started to. Anyway, good, nice, high, heavy-duty t-shirt. And a good cap. You know, I actually had an Alabama cap in my truck, and I took it out and I put my ICOM cap in there. So that's my sole cap I use now.
It is. Trying to think, is that an ICOM cap? I think it may be an ICOM cap in my truck, but it's the old model.
If it's not, it should be.
It's not the one with the gray. The snazzy new two-tone model there.
Yeah, these are nice. They're good heavy-duty caps.
Okay, we've got a lucky winner here from amongst those who drew or who entered. Did you tell them how to enter?
No, I didn't. If you want to enter for the drawing for next month, send an email to HamCollege@AmateurLogic.TV, and basically all you need is a name. You don't have to be a licensed ham or anything. Just all you need is a name and an email address.
And
anyway, if you emailed and got into one of the previous drawings, your name does not carry over. So if you want to enter again for the next month, be sure to send those emails back in each month.
Yeah.
So you can get added back to the drawing.
Yep. And this month's lucky winner is Gary Lindsay, W7MIN.
All right, congrats, Gary.
And Gary actually put a message in here. It says, "I enjoy the show."
Well, appreciate it. We enjoy doing it.
Yep.
And
thanks to all who entered, and to those who didn't, go right now or go after the show, HamCollege@AmateurLogic.TV, the email, and you might be next month's lucky winner.
Yep, a very good chance.
You could have your name read right here on Ham College.
That's a pretty big honor.
That means, not only do you get the hat and the shirt,
and you get the notoriety of it as well. So anyway, be sure to enter and put your name in the hat to win the hat and the shirt. Thanks for ICOM for sponsoring the show and providing those shirts and caps for everyone.
Thanks, ICOM. Well, before we get into the questions, I do just happen to have an oscilloscope handy here.
Who would have figured it?
And we mentioned something earlier. One of those questions said something about flat topping. I don't remember what that question was now, but it might be in that stack of papers that you've got right there in front of you.
Yeah? What is meant by the term flat topping when referring to a single sideband phone transmission?
All right. Well, this is not a single sideband phone transmitter right here. This is an audio oscillator, but it's the only thing I got handy that's connected.
Is that
in
upper
there.
sideband or lower sideband audio?
Double sideband.
Double.
Suppressed carrier. No, it is just an audio oscillator. I was just going to try to show maybe, and this is not exact either, what flat topping would look like. Say if your audio signal going in looked like this, but what you were getting out on the air looked like that. Drop it down there a little bit. It's flat on the end. It's not round anymore. Well, that's flat topping. This is just a real ugly square wave here coming out of this cheap oscillator, but
it would be similar.
It would be similar.
Kind of similar.
Except this is an audio signal and not a single sideband transmission, but you get the idea. Instead of being nice and rounded on the ends or facsimile of what went in, you chopped it off and it's flat now.
That's a sine wave. So it looks like a normal sine wave, but the tops, instead of being rounded, they're just...
That'd be flat. If it was a sound wave you were feeding in, if you're feeding in your voice or something like that, that's a complex waveform. It's the wave is a lot more complicated than just a sine wave. It's got peaks and valleys and all in it, but you would notice that it would just go out so far and then it'd just be flat on the ends. So same basic effect there. We'll leave this here in case we need it in a minute. I'm not sure if we will or not, but we could.
Yeah, who knows? It's handy.
Yep. All right, let's see. I think I asked you the last question.
Okay. Which of the following is an advantage of an oscilloscope versus a digital voltmeter? A, an oscilloscope uses less power.
B, complex impedances can be easily measured.
C, input impedance is much lower.
Or D, complex waveforms can be measured. And I'm surprised. Oh, there come the answers in the chat room right there. They're not coming in too fast, though. But they're all saying D, which is what I would say, or what I am saying. An oscilloscope versus a digital voltmeter. Well, all you can do with a digital voltmeter is measure a voltage. You can tell the amplitude of the voltage, but you can't tell anything about the waveform if it is, an AC voltage, or a really nasty, I guess, DC voltage with noise on it. You can see the voltage. Mm-hmm. That's it. With an oscilloscope, we just looked at one here, and we can see what the waveform actually looks like.
Across time.
Across time. So an oscilloscope uses less power. Not true at all. It uses more power. B, complex impedances can be easily measured. No, I didn't see a SWR setting on it, or an impedance setting. And you could use it with some other equipment and determine impedance, but not easily. C, input impedance is much lower. No, typically the input impedance of a scope is much higher. Why would you even care what the impedance was of a scope or a piece of test equipment? If it was low, when you hook that piece of test equipment up across your signal, you'll be loading that signal. It'll actually have some effect on what's generating the signal. If it's got a high impedance, like an oscilloscope, then the piece of equipment you're trying to measure doesn't really realize that you've hooked onto it. It still functions the same. So yeah, it's definitely not a lower impedance. D, complex waveforms can be measured. And as a matter of fact, we just talked about waveforms and speech being more complex. Mm-hmm. I couldn't see speech at all on a digital voltmeter. I could see the voltage going up and down, but I couldn't see, the nuances of the waveform like I can with an oscilloscope. So it's D. Complex waveforms can be measured.
Cool.
Which of the following is the best instrument to use when checking the keying waveform of a CW transmitter? A, an oscilloscope.
B, a field strength meter.
C, a side tone monitor.
Or D, a wave meter. Well, I'm just going to have to go straight to A, an oscilloscope on this one. So we're looking at the waveform, and checking the key and waveform of a CW transmitter. So that's out of those. That's I don't know what a wave meter is, but that's the only tool on there I see that's possible to even see a waveform at all on.
Yeah, a field strength meter couldn't really check a waveform with, nor a side tone monitor. You might think a wave meter, but no, a wave meter I think more or less measures frequency. So I'm going to agree with you. It's A, an oscilloscope. Everyone in the chat room's agreeing with you too. You got that one?
That close.
Yep.
What signal source is connected to the vertical input of an oscilloscope when checking the RF envelope pattern of a transmitted signal? A, the local the local oscillator of the transmitter.
B, the external RF oscillator.
C, the transmitter balanced mixer output.
D, the attenuated RF output of the transmitter. What signal source is connected to the vertical input of an oscilloscope when checking the RF envelope pattern of the transmitted signal? Well, if I want to look at the RF envelope pattern of a transmitted signal using an oscilloscope, I really wouldn't care about looking at the local oscillator or an external RF oscillator. I mean, that's external. That wouldn't have anything to do with my transmitted signal. The balanced mixer output really wouldn't help me much. What I want to see is the output of the transmitter, and I got to attenuate it. I don't want to take, a kilowatt and run it straight into my oscilloscope and burn it up. I want that signal to be attenuated down to something my oscilloscope can handle. So I'm going to say it's D, and that's what they're all saying in the chat room.
I think so.
Yeah. There you go.
Here, I gave you one of those. I hadn't gave you one of those yet.
Okay, I was just thinking I was overdue one.
You were.
Yeah. Oh, you know what?
Time to go home.
No, that means we're going to change subjects. Not really a whole lot, but we're going to get into our electronics, what we call the electronics questions of the show here.
Okay.
And we're going to take a little break while I get those together and swap out the test equipment we've got here. Are you new to the ham world or an existing amateur operator who wants to take your license to the next level? Study for your radio license exam at hamstudy.org. Hamstudy.org is a free online learning tool powered by ICOM. It was created by Richard Bateman, KD7BBC, Michael Stufflebean, KV9G, and Rich Porter, KK6GKE, and it uses a modern web design to enhance the experience of studying for your technician, general, and amateur extra exams. Since 2013, hamstudy.org has helped new and existing hams to familiarize themselves with the question pools, use stats-based flashcards to focus on material they need to learn, and take practice exams to gauge progress. Visit hamstudy.org on your desktop computer or mobile device. Register for a free account at hamstudy.org to access personalized study history and other site features. Prepare for an exam in an intuitive and comprehensive manner. Check out hamstudy.org, powered by ICOM, for free learning tools. Good luck on your next exam.
Busy day, busy, 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 too busy, too busy. Oh, Herbert! Dinner time, oh, dinner time. Too late to make dessert.
Wait, it's not too late to make dessert. Never too late anymore, because now the Jell-O family of famous desserts brings you new Jell-O instant pudding that needs no cooking. Just add to milk and beat in minutes. This terrific new busy day dessert is ready to eat. Creamy, nourishing, so delicious, and so quick you can make it just before dessert time while the children are clearing the table, or let the children make it themselves. It's that easy. New Jell-O instant puddings are at your grocer's now. Stock up. with a terrific new busy day dessert, new Jell-O instant puddings.
With the success of the recent Apollo space flights, man has been brought another step closer to the moon. Aboard these manned Apollo flights, 3 astronauts, and with them, Tang. Tang, the energy breakfast drink with rich natural flavor and more vitamin C than orange juice. Still, Tang's biggest role isn't in NASA's space program. It's right here on Earth.
In a world of fun and fantasy and ever-changing views and computer terminology, Commodore is news. Are you keeping up with the Commodore? 'Cause the Commodore is keeping up with you. Are you keeping up with the Commodore? 'Cause the Commodore is keeping up with you. Are you keeping up? 'Cause the Commodore is keeping up with you. Are you keeping up? 'Cause the Commodore is keeping up with you. In a world of high technology and ever-changing moods, in a world that's full of make-believe and changing attitudes, are you keeping up with the Commodore? 'Cause the Commodore is keeping up with you. Are you keeping up with the Commodore? 'Cause the Commodore is keeping up with you.
At Dick Smith, we've lined up the best ever deals for our biggest ever Boxing Weekend sale. Friday, Saturday, Sunday, you'll save 15 to 40% off a massive range of products and brands store-wide. Dick Smith's biggest ever Boxing Weekend sale. Must end Sunday, don't miss out.
This is one I should ask you. I should probably ask you all the rest of them if we're looking, since I typed them in here, you know. We got a better chance
Did you get the buzzer?
Buzzer, maybe. Maybe not. Which of the following must be connected to an antenna analyzer when it is being used for SWR measurements? A receiver.
B, a transmitter.
C, antenna and feed line.
Or D, all these choices are correct. Well, all these choices are not correct. So it's not D, which to the antenna analyzer for SWR. We're not talking about just connecting, just checking the SWR. So you don't really have to have a receiver or a transmitter for that, because the antenna, the SWR analyzer, will act as the transmitter.
Good point. Yeah.
All we need is C, antenna and feed line. So I'm saying the answer is C.
So you're saying an antenna analyzer would analyze antennas?
I know, as crazy as it sounds.
Well, that's what most of them are saying over in the chat room, and I agree. As a matter of fact, you know, somebody who's not a ham yet, there's a good chance they've never seen an antenna analyzer.
It's a good chance. It's a good chance when they see one of them, they're going to want one of them too.
It is, and you know, I should have actually had an antenna here so that we could demonstrate it.
Go get the one off your truck we need to check.
Well, yeah. Maybe I should just bring my truck in here. I think this one's got batteries in it.
This was my most coveted piece of gear that I wanted when I first was a ham, and with the exception of a new radio. But.
And if you're like me, you didn't get one right off.
No, I didn't get one, but I wish I would have.
And this, what this has got on it.
See the screen there.
Well, the meters are pegged out here, and
that's because you got a high SWR running out.
Well, it's greater than 25, so yeah, it's not that good. You hook your transmission line here that goes to your antenna, and you adjust the frequency you're interested in, and you can see right here the SWR. You can also see the impedance of it, and it'll give you the impedance and reactance, or the resistance and reactance, excuse me, right up here on the digital display. So you get a lot of information right there on that antenna you're trying to measure. Now, before we had these, and this one is MFJ 26. This is a 259.
Yeah, I think it's a 259C.
You got the 269.
I think I got a 259B.
259B. Okay.
And that this is the C.
All right. And so this is
think.
one of the most popular antenna analyzers ever made, and it's one of the first, a newer revision of it. Here's another one right here. This is an MFJ 225. This one I don't have batteries in it right now because I don't leave them in there because it's not something you use every day, and I don't want the batteries to go bad in there and corrode up my
It's not something
test
you use
equipment.
every day, but when you need it, it's a good thing to have.
Now, it does the same things that other analyzer does, except it has a graph on it so you can see the SWR over a frequency range. So I like looking at it this way, graphically.
Yeah, me too.
That's my preferred
Because you can basically
method.
sweep the whole band that your antenna covers and make sure that, where you're good and where you're not.
Yeah, and you can see where your antenna is resonant easier. You can do it now, no problem doing it on the other one. It's just going to take a little bit longer. So these are pretty nice. Before we had that, well, we were old school. We were using SWR meters, and this is the first SWR meter I ever owned. This is an old Pace CB.
Yeah, I used to have one exactly like that. I haven't seen it in about 40 years, though.
Yeah, this one was from, I probably got this one in the mid-70s.
Yeah, that's about
So
when I would have had mine.
It's got some age on it. So we can see our forward power, and through some wizardry of flipping switches and adjusting knobs, we can read the SWR with that. But we've got to put our transmitter in and hook our antenna and feed line on the other side. You can check your antenna with this. You can't check it as fast or as easy as you can with an antenna analyzer, though. But if you can only get, this is a lot less expensive. This is probably where you're going to start out. Maybe not with a CB watt meter by Pace, because I don't even know that they're still in business. But you probably, good chance you'll start out with some kind of watt meter, SWR meter combination. And, when you're ready to invest a little more, go to an antenna analyzer.
Yeah, but this is set up to cover one band. This covers a wide range.
Yeah, but now this is just for a CB. If you went out and bought a HF watt meter or a VHF watt meter, it's probably going to cover the band you're interested in.
Yeah.
So, guess you asked me this one.
Okay. What problem can occur when making measurements on an antenna system with an antenna analyzer? A. Permanent damage to the analyzer may occur if it's operated into a high SWR.
B. Strong signals from nearby transmitters can affect the accuracy of measurements.
C. The analyzer can be damaged if measurements outside of the ham bands are attempted.
Or D. Connecting the analyzer to the antenna can cause it to absorb harmonics. You think you know the answer to that one?
I think so.
Okay. Is it the same one everybody thinks it is in the chat room?
Yes.
No, well, then no possibility of a buzzer there then.
Not on that one.
It's B. Strong signals from nearby transmitters can affect the accuracy of the measurement. So, yeah, if you're using an antenna analyzer, you're operating down at such a low signal level, because you don't need much signal level, that if there's another transmitter in the vicinity on a nearby frequency, you're going to pick it up on that antenna. It's going to get into the analyzer and throw your readings off.
Yeah. Although I've never seen that happen, but it's a possibility.
Yeah, it can happen. And AM broadcast, sort of like HF, it's down pretty low frequencies there, although it's the medium frequency, medium waves. Yep. We had antenna system over here that I've got one of my AM stations located on. There are 3 AM stations on this one tower. There's this huge conglomeration of matching devices, combiners, antenna networks that 3 different 5 kilowatt transmitters run into, and it all comes out one spigot and goes to a tower.
Oh, wow.
Without one interfering with the other. It is very expensive. Very, very expensive to set up. And we had to have a consultant come in and spend like a week and a half tuning it, set it up.
Wow.
He brought a lot of test equipment with him. Essentially, stuff similar to what an antenna analyzer would do. There's another station down the road about 2 miles from that site.
Mm-hmm.
So how could he measure it on that tower with another AM station nearby without it affecting his readings?
That'd be tough. Because that other station you're talking about used to come in on my telephone back when we had landlines.
Yep. Yeah, it used to come in on mine too. Of course, I lived there, but
yeah.
An ingenious solution there to it. He had an amplifier, 100-watt amplifier, that he would run his analyzer, the signal generator for his analyzer through.
Oh.
So he was sending 100 watts up that tower, and so that was strong enough that the other signal down the road wasn't interfering with what
So
he
he had
was
his
trying to
own
measure.
private key down contest on the his
Basically.
antenna analyzer.
Yep. So that's how you do it. You run more signal. But the antenna analyzer, you're running tiny little bit of signal because that's all you need.
Yeah, well, that
Unless
makes
you're
sense.
getting
That's a
interference.
good solution.
Strong signals from nearby transmitters can affect the accuracy of measurements.
I will
All right.
say we haven't heard the buzzer yet, but I will say the questions have been actually pretty interesting tonight to me.
They've been a lot more toward technical and electronics
Yeah.
and radio type of stuff. So why don't you try me?
Okay, here's one for you. What is a use for an antenna analyzer other than measuring the SWR of an antenna system? A, measuring the front to back ratio of an antenna.
B, measuring the turns ratio of a power transformer.
C, determining the impedance of an unknown or unmarked coaxial cable.
And D, determining the gain of a directional antenna. I wasn't really paying attention when you asked the question, so I better read over it again before I answer. What is the use for an antenna
If you don't
analyzer?
read it, we might get a buzzer.
Well, yeah, that's what I was thinking. What is the use for an antenna analyzer other than measuring the SWR of an antenna system? Measuring the front to back ratio of an antenna? Can't do that. B, measuring the turns ratio of a power transformer? No, I don't think it can do that. D, determining the gain of a directional antenna. No, it doesn't know anything about gain. C, determining the impedance of an unknown or unmarked coaxial cable. I'm going to say it's C. And that's what they're saying in the chat room. As a matter of fact, in a couple of recent episodes of Ham Nation, I did a demo of exactly that.
Oh.
Determining the impedance of a cable using an antenna analyzer. And so it is C. And what I was trying to do is, the first video I showed on there 1 week was one where I was using this antenna analyzer right here that I had shot that video for AmateurLogic several years ago.
Mm-hmm.
And so I replayed it on Ham Nation and, showed how you could measure the impedance of an unknown cable. And I wondered, could you do that with another analyzer? Because I had some analyzers like this that have graphs on them, a graphing type analyzer, and their instructions didn't tell how you could check the impedance of coax.
Oh, interesting.
So I used the same procedure on them, and I found out In most every case, you could. That worked. I only found one analyzer that it didn't really pan out on.
Huh.
But out of like 5 I tried, 4 of them could do it.
Oh, interesting.
So that was interesting. Yep, I did that on Ham Nation, Dennis. Let's see.
It was on Amateur Logic years ago.
Oh, yeah, it was.
It was a long time ago. I remember that. It's just been so long, I can't remember when it was.
It was like magic.
Yeah?
To me at that time.
Yeah.
There's a lot more you can do with antenna analyzers, and we're probably going to be looking at some more of them.
Cool.
Which of the following instruments may be used to monitor relative RF output when making antenna and transmitter adjustments? A field strength meter.
B, an antenna noise bridge.
C, a multimeter.
Or D, a Q meter. Relative RF output when making antenna and transmitter adjustments. Well, I'm gonna have to go. It's not a multimeter. It's not a noise bridge, and it's not a Q meter. It's going to be a field strength meter.
So you're saying it's A.
I'm saying it's A right there.
And wait a minute, that's an SWR meter.
It's also a field strength meter.
Oh, it is.
Yeah, that's what the antenna's here for. Well,
that is what it's for.
Yep. You can get it near the transmitter output of the antenna. Well, yeah, you got the wrong. Get it near the antenna, or in a certain range of it where it can pick it up, and you can actually measure the output. So you could use this to measure basically front to back ratio of your beam or the pattern of your antenna.
And you could check various antennas.
Yeah.
With it. As a matter of fact, this little meter right here came with the field strength meter built into it. It was a simple affair. It didn't really run up the price of it any. And a lot of meters of that vintage had that built in there. But like you say, you got to be kind of near.
Yeah, you got to be pretty close for it to work.
Yep.
And that's why it says relative.
Well, one of my AM stations is 50 kilowatt AM station is as high power as you can have on AM in the U.S. At night, it has to reduce power and go directional so that because we got skyway issues on AM at night, and we're protecting other stations to the north, so we have to switch in 3 towers and a directional array, turn our power down to like 500 watts, and aim that radiation coming from that station in a particular direction that there's no other station, so we're not interfering with anybody.
Oh.
So it's a very expensive proposition because you got to have, in this case, 3 towers. You could do it with 2 towers. You get certain patterns out of it, but what we needed was going to take 3 towers to pull off. Some stations may use 6 or more to do that. You have to check your front to back ratio and the coverage of that, where it's going. So what instrument would you use to do that?
A field strength
meter. But I can't do it with this one.
No, probably, and you're probably going to have to get a little bit farther out than you would use that one.
You are. And so we do use a field strength meter, and I had to buy one it was either 2 or 3 years ago for work because we needed one that we could take those measurements with and have on hand there for doing it. It wasn't just like they stuck an extra diode and a whip antenna on a SWR meter. It was about 15 grand.
Oh, wow.
But it is precision calibrated instrument, probably one of the best AM radios in the world too, because that's all it is, AM radio with a loop. So I guess you would
use that in conjunction maybe with a GPS?
It had the GPS built in it.
Oh, okay.
So I could actually go out and find the exact spot I was supposed to be standing to take that measurement.
Oh, that's cool.
Which, not too many years have you been able to do that. You had to take out topographical maps and draw radials and stuff and figure out exactly where you needed to be standing.
Yeah.
Now you can just walk out with a GPS and be right there if you got 15 grand. Well, let's see.
Nothing little money can't take care of.
No, it wasn't my money.
Or a lot of it.
Yeah. Well, let's see what we got next here.
Okay.
We never answered that one, so
Oh, well,
you
I
did, but
I
we
did.
didn't. We didn't
Okay.
flash it up there. Let's see if we've got any questions remaining tonight. You know,
We ought to be getting near the end.
we're getting pretty close to it.
Which of the following can be determined with a field strength meter? A, the radiation resistance of an antenna.
B, the radiation pattern of an antenna.
C, the presence and amount of phase distortion of a transmitter.
Or D, the presence and amount of amplitude distortion of a transmitter. What can be determined with a field strength meter? Well, it can't determine the radiation resistance of an antenna. You'd come closer to doing that with an antenna analyzer or something like that. D, the presence and amount of amplitude distortion in a transmitter. You can't really measure distortion with it, so you can't do C either. Can't determine the presence and amount of phase distortion. But, as I was just talking about a minute ago, it can measure the radiation pattern of an antenna by moving around, checking your signal. You can take that and plot that out on a chart and see exactly where your signal's going.
Yep.
So, and most everybody got that over in the chat room there. We did have some say D. Yeah, I don't think you could do D with it, so it would be B. No, we didn't. They said little b instead of capital B.
Oh.
Nobody said D.
I was trying to figure out who
Okay.
said D.
Yeah, because I looked at the people that said it, and I said, no, those guys know the answer. So, yeah, it's B. Well, I think that's all the questions we had
And
tonight.
no buzzer. We made it through the whole year without getting a buzzer.
Not the whole year. We made it through the rest of the year.
It sounds better like that.
Well, it does. It's not really the truth. And, you know, here at Amateur Logic in Ham College, we're all about
We're
the
always
truth,
seeking the truth.
or as close to it as we can get.
Yeah.
Sometimes we skirt around the edges a little bit, but that's our aim.
Yeah.
It's right
We
there.
try to shoot it straight here.
We do. So, Tommy, did you get everything for Christmas you wanted this year?
Actually, I did.
What did you get?
Well, I could have used another shirt.
You could have.
Yeah, another Amateur Logic shirt.
Well, you're in luck.
Look at that.
Yeah.
I got everything but that, and I was kind of disappointed.
You know, I didn't get that either.
Yeah. I guess we're going to just have to go to AmateurLogic.Spreadshirt.com and get our own.
We can get what, hats?
There's hats,
Even.
jackets, sweatshirts.
T-shirts?
There's Amateur Logic and Ham College swag on there.
Yeah, I think this time of year you might want that Ham College sweatshirt. And I thought about tonight
Me
wearing
too.
that, but it's just,
It's
you know,
it's just borderline.
it's just, yeah, it's a
on,
little too warm tonight for a sweatshirt down here.
Maybe next month.
Maybe next week. Yeah, well, we won't be doing a Ham College next week, but
But anyway, go to AmateurLogic.Spreadshirt.com and get yours. And if you do send your pictures in, we've been showing people with the swag pictures and the traveling hat and so forth over on Amateur Logic. So send yours in too. Those are really fun.
yeah, we'd like to see them. You said something there, and I had a catchy phrase to go with it.
Well, let's hear it.
Well, I don't remember what it was
already
even
went,
about
huh?
now. I know what I was going to say, but I just don't remember why. We're going to be celebrating New Year's right here. Well, I'm going to be right here. You're going to be,
I'm gonna be on the other side of town.
but we're going to be doing it nevertheless.
We're gonna be doing it together.
Yep. And we're going to have some friends in with us right here, live.AmateurLogic.TV, New Year's Eve, starting at 8 p.m. Central, 0200 UTC. We're going to be celebrating New Year's Eve. We don't know exactly what we're going to do yet.
So it'll be just like business as usual.
Pretty much. It'll be Dean Martin here and myself, and I think we're going to have Mike VE3MIC join us, and Dan N9LVS, and I believe
Amanda and Jeff.
Amanda and
will
Jeff.
be here.
Amanda, the chat room queen from
The chat room
Ham
queen.
Nation. Yeah.
And probably some others.
Probably some others. We haven't heard back from everybody yet, and I've got a few here that I haven't been in touch with yet, but
But it should be a good time, though.
yeah.
I've seen some of the stuff.
Yeah, you have.
So,
Yep.
matter of fact, I laughed and laughed. I haven't laughed that hard in a long time.
You know, that was some pretty funny stuff.
It is very funny. So anyway,
You'll have to tune in to see it. And, you know, anytime you got VE3MIC involved in
Gonna
something
be some
like
laughter.
this, yep, hilarity will ensue.
Nigel says he'll join us.
Yeah, join us.
Yeah, come on.
0200 UTC, Nigel.
Yeah. So
Of course, you won't get to see it till next year.
Yeah, I guess so.
I guess so. And Peter won't be with us this year from down under. I think he's got to work that day.
Oh yeah,
Yeah.
that's no fun.
No, that's not fun.
It's a 4-letter word.
Yep. Anyway, we're going to have a few maybe highlights from the past years, that some of our favorite segments, but that's not what the show is. I mean, it's not really just a rerun of the year.
No, not at all.
Yeah,
It just should be a good time. Just come drop in and check it out. I think you'll like it.
yep.
I didn't get to attend the last one, but I'm looking forward to this one.
I'm looking forward to it too. It's going to be a fun time. Well, I guess that's going to do it for tonight. On the way out the door, a couple of things we do want to mention. Number one,
Yep, you can find us on the social networks at facebook.com/groups/AmateurLogic.TV. We also have a Ham College group on there.
we do.
It's not very active, but it is there.
It is there. We've got the Google Plus pages. The communities
for a while
remaining.
longer.
I think April is when Google's planning on shutting down communities now. So we'll have it there to then. And you can follow us on Twitter, 2 different addresses.
At Amateur Logic and at Ham College. We also have an Instagram account, but it's mostly only used during Ham Fest and things like that. But if you want to see some pictures posted from some of the things we attend from time to time, join us over there as well.
And we still got the wiki out there. Matter of fact, just did a little updating on it. Friend Dan N9LVS helps us with that. AmateurLogic.TV/wiki. You can get the Amateur Logic and Ham College wiki show notes there, and links that we mentioned in some of the episodes and such.
Yep. If you want to go back and reference some of the older shows, that's the first place to go to search there and see if you can find it.
That's it.
what we do.
All right. Gee, I guess that's going to do it for tonight. That's going to do it for the year.
Yeah, I guess we'll see you next year.
See you next year, unless you tune in for that live stream on, is it Tuesday night? No, Monday night.
It's Monday night.
Monday night.
Yeah, so watch the usual places. We'll make the posts, and the chat room will be open. Usual hijinks.
Yep.
Should be a great time.
Yeah, join us New Year's Eve.
Yep. If you don't join us, don't drink and drive. Be safe out there.
Exactly.
And
if you do join us, don't drink and drive.
Yeah.
You probably shouldn't be watching while you're driving anyway.
True.
Although you could listen.
73, everybody. See you next
73.
year.
Happy New Year.
What is the purpose of doing a two-tone test?
That is to check the linearity of the signal. What my assistant said.
From the roof?
From the roof, yes. Intermod, do you know what that is?
Oh, I certainly do.
Tell me.
That's when you have two signals that mix, and you have basically a product of it, and it causes the squelch to break on your radio, like when you're driving down I-55 past High Street.
Exactly like that. You know, I think I'm going to have to go cure a little intermodulation distortion right now.
You want the modulation?
You mean that mop sitting over there?